In this video, I will cover Executor framework in Java. Executor framework introduced in fifth version of the Java. It provides Threadpools in the form of Executor interface, which allows Java programmers to decouple submission of a task to execution of the task. So Threadpool is a pool of worker threads which is ready to perform any task given to them, mostly in the form of implementation of runnable and or callable interface. So in real life web applications, so we need to run separate thread for each client request. So we need to work with a group of threads in this case. So creating a thread in Java is very expensive process which includes memory overhead. Also using thread class classically in Java, we cannot reuse the task once it is done. Threadpool provides us to ability to solve these problems. So with Executor framework, we can just reuse the task. So we can just schedule this task and manage them. So in the new Executor framework, we use a callable interface. Along with the runnable interface. So callable interface is similar to the runnable interface, but callable interface can just return some variable. So callable interface is a generic class type parameter of the callable interface specifies what kind of data will be returned in the call from the call method. So in Executor framework, if we need to return some result, we use a callable interface, or if we don't need to get result from the task, so as void, we can use a runnable interface. So future interface represents the result of an asynchronous computation. So when we use callable interface in the executor after the calling, so the as a result we will get a future instance of the future interface. So in this case, it provides us the ability to get result in the future. So it called feature because the result will not be available immediately. So we can just invoke, we can just we can just get the results from the future interface later. Future interface has several methods listed here. So it is a cancel method which attempts to cancel execution of the task. Is cancelled method to check if task is cancelled, and is done method to check if this task is completed. Also get method to get the result. Let's see the implementation of the future interface. So in this case, yeah, get method has overloaded once. So first get method without argument will wait the task will wait the task for complete thing for finishing. But second method, we can just specify as arguments the timeout and time unit variables. So when this timeout expires, it will just throw a timeout exception, and we can just perform this exception properly. So using try catch blocks. So in this case, first timeout specifies that the length of the time, how much time we can just wait to get the result. And second argument is time unit variable. It decides. It specifies the metric of the time, so we can just see here. It's a non-variable which can be nanoseconds, microseconds, milliseconds, or so on. So let's see some example using the callable and runnable interfaces. So in this case, we have the task which my callable which implements the callable string interface. So in this case, let's see that it will return the name of the current thread. Uh, we using executor service. We can just submit this callable, and then it will be started. Also, we will just get this result using get method. So using future method, we can just some codes here. Also, it will be simultaneously. We will not need to just wait for the task to be completed. In this case, when we need some result from these tasks, we can just get the result later. So let's run it. So in this case, it gets the result here. We can use time unit, for example, some time, and then it will just time arguments milliseconds, and it requires the we can just perform this exception. So in this case, timeout expired because in my callable, if you see that it will it will sleep for the 1 second. Okay, let's continue. So the core of Executor framework is Executor interface. So it's a root interface in this framework. So this an object of type executor can execute runnable or callable tasks and callable tasks. So it provides us only one method, one abstract method, which takes runnable command and which executes the given command at some time in the future. The command may execute in a new thread, in a pull thread, or in a calling thread. It depends on the implementation of the executor interface. So executor interface also expands with executor service interface, which provides more methods listed here. So in this case, it also accepts callable objects, as we say that, uh, which allows to return value. Also, it provides methods for submitting large collection of callable objects, and it provides a number of methods for managing the shutdown of the executor. Okay. Also, we have scheduled executor service framework, which is capable of scheduling tasks to run either periodically or once after a certain amount of the time has elapsed. So we have two methods. It's a schedule at fixed rate method and schedule with fixed delay method. In this case, when you use a schedule at fixed rate method, you so we need to just as a rate, we need to just give some more time. We need to be more carefully using this method with times, because it will not take into account the actual duration of the tasks. So if we specify a period of 1 second, but the task needs 2 seconds to be executed, then the thread pool will work into capacity very soon. Also, we have Executors class with S, which is similar to the collections class in collection frameworks. So it provides several static methods to create various type of thread pool implementation in Java. Also, it provides, so we can see the Executors class here. We can see that it provides not only the factory methods. It also some utility methods to just. It also provides some another methods to work with executors. Okay, executor factory methods. So we can create it's four types of them. So we can create executor implement instance of the executor using these four methods. So firstly, new cached thread pool, which creates a thread pool that creates new threads as needed, but which reuses previously constructed thread when they are available. So in this case, threads that haven't been used for 60 seconds are terminated and removed from the cache. This thread pool typically improves the performance of the programs that execute many short-lived asynchronous tasks. Also, we can just use a new single thread executor, which creates an executor that uses single worker thread to operate. So when we use more several runnable when we add several runnable to this executor, uh, it will be executed waiting each other, so in a queue. So also we have a new fixed thread pool with specifying count of the threads. It's the same as new single thread executor, but with it will just so firstly the end threads will be run it, and if this threads count is more than n threads, it will just wait for finishing or terminating the threads in the executing in the pool. Also, it will just when some thread crashes or or finishes. So in any case, it terminates. Then the threads in this case will be started automatically after the terminating the threads. Difference between new single thread executor and a new fixed thread pool with one argument as one is that you cannot change thread pool size in the first case, but in the second case we can uh, call set core pool size method to specify the new count of the threads in the thread pool. Also, we have a new scheduled thread pool class to create a thread pool that can schedule commands to run after a given delay or to execute periodically. So let's see examples. Mm, Okay, let's just remove it and then so it's cached threads. So in this case, uh, okay, let's run it. So in this case, we can add threads using submit method to threads, and then we can get the result. So we can just check the pool size, maximum pool size, active count, and task count. Okay. Also, the next example is single thread. So in this case, we can just run it. So let's see running it. So in this case, it's wait. So to start the second thread, it waits for the first thread to be finished. So loop task is a runnable threads. So it's finished, and then uh, after then this the second thread is started using the fixed thread pool. We can just use same tasks. So in this case, for example, our thread pool, so when threads variable is 3, so in this case, so these three threads starting simultaneously and working simultaneously. So, but the thread 3, thread 4, or thread 5, it's selecting uh, Thread 5 started after some time when this thread when the threads in the thread pool finished. Running threads in the thread pool finished. Finished. Okay. Also, we have new scheduled thread pool. In this case, you can run it and then see the result. So in this case, we give them the delay and we use schedule method. So we can schedule at fixed rate method to just mm, to just start this method to run this task in some rates, so periodically. Also, we can just here run it using the next task. Okay, in the next task we can just use it to run it in a delay. So in this case, we can just see that it starts after the 5 seconds as we need. So also we can use to just communicate between threads. We can use pipe streams, so pipe reader and pipe writer classes. So in this case, we have some restrictions, so we cannot write up to pipe without having some sort of reader created and connected to it. In other words, both ends must be present and already connected for the writing end to work. We cannot switch to another reader to which the pipe was not originally connected, and we cannot read back from the pipe if you close the reader. We cannot read back from the pipe if the thread which wrote to its ends. So let's see the examples. So in this case, where is it? Ah, here. So let's let's run it and then see what is going on. In this case, Pipet writer. So Pipet reader and Pipet writer. Also Pipet reader connected to the Pipet writer, and then thread writer threads writes to the pipet writer. So pipet reader reads here the pipet writer's data from the another thread, from the reader thread. Okay, so it's over.